Okay, number 5. Our acceleration is equal to 0, so it's going to be a constant 0. Now, and just as a reminder, acceleration is a constant 0 only for the purposes of our class. Can acceleration change over time? Well, sure it can. But that's going to be beyond the scope of what we talk about. For our purposes in our class, acceleration will always be constant, whether it's positive or negative or 0. It's not going to be changing on us. Like, for example, gravity. Gravity, for the most part, unless you go into outer space, on Earth pulls on us at a constant rate. So it's not going to be changing as you move around. So the accelerations we're going to be talking about are going to stay constant. So, okay, well, what does that look like? Well, 0 and constant looks just like that. What's our v of t? What's our velocity as a function of time? Well, it's on our initial velocity plus at. Of course, our initial velocity is 0, and our a is 0. Well, what's that look like? Well, that means 0 plus 0 is 0. Well, what about time? Where does time factor in? Well, that means it doesn't matter what time it is, whether you're 1 second in or 10 seconds in. That means velocity is always going to be 0. So it starts at 0 and stays 0. Or you could write it like this. You could really write our velocity as a function of time is it's just our initial velocity, which we're told is 0, and it stays that way, so it just stays 0. And we have our displacement. What's our equation for it? Well, that's xi, our initial x, plus vi times t. Well, that goes away because vi is 0, and plus 1/2 at squared. That goes away because at is 0. So really, all we have is, well, what's our xi? Well, it's some value greater than 0, so it's going to start up here. So that means that our object is starting at a position greater than 0 and is staying there. Velocity is 0 and acceleration is 0. So what's this object doing? It's just sitting there. It's not moving at all. It is it starts displaced some distance from 0. So that's our xi distance right in there. But it's not going anywhere. And so that's what the graph for that looks like. So that'll be number 5. Number 6. Moving along here. Okay, our acceleration is less than 0. So it's going to be a constant negative. Right there. So pick a negative spot for our acceleration and make it stay constant. Velocity times time. Okay, remember velocity times time is vi plus at. That is our initial velocity plus acceleration times time. So our initial velocity is greater than 0. And since our acceleration is negative, I'm going to, again, write it like this. So it's minus the absolute value of acceleration times time. Again, you could write it vi plus at, but since our a is, that says that's going to be a negative a right there, I'm just putting the negative out front, so we're reminded that the whole second part is negative. So we're going to start with an initial positive velocity, but we're going to have a negative acceleration. Well, what is our initial velocity? It's something positive. It's something greater than 0. So it could be 1, 2, 3. And what does it look like? Well, we've got this a right here, this negative a. The value of that is the slope of the line on the previous graph. So it's going to be sloping down just like that. That is, this negative slope here is the same thing as this negative value. Okay, position as a function of time. Well, it's our xi which is 0, so that goes away, plus vi times t. We can put that in there because vi is positive, plus 1/2 at squared. But again, since our a is negative, I'm going to put minus 1/2 of the absolute value of a t squared in there. Now again, if you simply wrote this as vit plus 1/2 at squared, that would be 100% correct. But remember, if you were given a value for a, like, I don't know, -2, -3, when you plug that in for a, you would also change this sign out here, right? So I'm just doing it without plugging something in for a, because we don't really know what a is, as a reminder that this acceleration is going to be negative. It's going to be negative. So this is, again, hopefully this is clearing up why I'm writing it like this, but just a reminder that our acceleration is going to be negative. Okay. So how do we write this? Well, our initial position is 0. So we're going to start here. Okay? Our initial displacement is 0. What's our initial velocity? Well, it's something greater than 0. So we've got an initial, or a positive initial velocity. So that means we're going to have a line going like that. And it's going to go up. And at some point here, it's going to stop and come back down. Now you may have drawn this a couple different ways. Since, look right here, this, I'm going to change colors here so you can take a look at it. On our velocity versus time graph right there, our velocity starts at some positive value and becomes 0 and then becomes negative. So that means the same thing must be true for our, if our values are true of that, or that's true of our values over here, that must be true of our slopes over here, which means we need to start, so we're starting with a positive value, we're starting with a positive slope. At this time right here, we must have a negative slope. I'm sorry, a 0 slope, because that's 0. And over here, we've got to have a negative slope. I'll change it. I should have centered this a little bit better, but that's okay. Well, that's really negative. I'll just do it like that. Let me try one more time. Still not the greatest, but you get the idea. We have an initial positive velocity, but since the acceleration is negative, it's going to start trying to make our velocity more and more and more negative. It keeps tugging us the opposite way. So it goes from a positive velocity to no velocity right here, because that slope is 0, and that tells us right there that it's 0. And then it becomes a negative velocity and gets more and more negative. Okay, so that is number 6. Now, I think on my key, the way I drew it was, this was, the second graph was more centered, and so it made our parabola more centered. But I'm not going to go back and mess with that right now. The shape is the same. And as long as you understand why, that's the important part. All right. The home stretch here, number 7. Our acceleration, what is it? It's a constant 0. Constant 0, and that means that looks like just like that. All right. Our velocity versus time. Our velocity is a function of time. So it's VI. Well, our VI is negative here. So I'm going to write it as a negative absolute value of VI. And what's our acceleration? VI plus AT. Well, that's 0. So that means the AT part goes out. So it really just tells us that we have a negative initial velocity, and it stays that way. So let's pick a negative value over here. Something like that. All right. And displacement as a function of time. Well, our initial displacement is greater than 0. So we've got a positive xi right there. So our equation for it is initial displacement minus the absolute value of initial velocity times time, right? Remember, I write it like that, so we remember that it's going to be a minus velocity, plus 1/2 at squared. Well, the a is 0, so that goes away. So this right here is really our expression for our displacement as a function of time. So let's graph it. What's our initial displacement? It's greater than 0, so we're going to start up here somewhere. Okay. What's the slope of our line? It's going to be sloping down. That's what the negative tells us. And what is the actual slope? Well, whatever this negative velocity is right there. So we'll say, I don't know, it's -2. That means we're sloping down as we go to the right. Something like that. Okay. Finally, number 8. Number 8, our acceleration is greater than 0, so it's constant positive. Let's pick a positive acceleration and draw it like that. Our initial velocity is also positive. Okay, so our equation is going to be VI plus AT. And good, okay, our acceleration is positive, so that will stay in there as well. And what is our initial velocity? Well, it's something positive, so we'll start here. Oops, try that again, right there. And it will be a positive slope. And what is that positive slope? That positive slope is this value of a, which we don't really know what that is in there, but we'll call it 1 or 2. Doesn't really matter, but it's just a positive slope with that slope. And our displacement versus time. Well, it's we have a negative xi, right? That's what that means. It's less than 0. So I'm going to put in that it's a negative absolute value of absolute value of xi. That's those are absolute value bars. They're not parentheses. Plus initial velocity times time, because that's positive, plus 1/2 at squared, because the a is positive as well. So this means we're going to have a positive initial velocity, and we're going to have a positive acceleration. We're simply going to start at a negative point, or a negative displacement point right here. So what's our initial velocity? I don't know, something greater than 0, so we'll call this, I don't know, let's call it 1. Vi equals 1. So that means our starting slope is going to be 1. And since we have a positive acceleration, it's going to be getting greater and greater and greater. So it's going to just be sloping up like that. Starting from a negative position, but starting with a positive velocity, and it's getting more and more positive because the acceleration is positive too. So there you have it. 1 through 8, review on kinematic graphing.